Everyone for attending the presentation over the topic cyber forensic detection of forged images, a multimodal and resilient approach. This is an initiation towards the cyber forensic field, as we have seen a high increase in the cyber crimes and synthetic media, which are having a high impact on the cyber forensic method. So today I'll be walking through the problem and the literature review, architecture design, methodology, evaluation, and forensic case study that I've demonstrated in the real world applications. So let's get started. So this is the most relevant topic as we are seeing a large number of manipulated images that are threatened by the cybersecurity area in the digital evidence. So traditional detectors are having a lack of interpretability and robustness. So this has made me think about this gap and addresses using a multimodal fusion and uh, through this and getting a high confidence result in this region. So the real motivation is from the cybersecurity field where manipulated image can be weaponized. For example, fake images can be used to fame someone, say fame any individuals, and falsely finance transaction and manipulate public opinion. So even different platforms like social media, Twitter, Facebooks are even destroying many clues that are forensic tools depending upon. So so that was the main problem which we all were facing. So that is the main motivation to get into this field. So this established a research gap, and the system relying only on one kind of mode was not possible. So far, we have all the previous literature work being done on single model, and we have multiple applications which are into concentration. So this is one of the method where all four concentrations of the forensic are taken into consideration and made in one go. So the research aim So from 2020 till there was a vast increase in experimentation in this part of the field, as we are seeing a high number of crime rates increasing in this field. So, but all these features lacked same thing, like there was no one single module which was able to produce all four results. So this was introduced, and the traditional was actually recompressing and resizing the images. Therefore it was lagging compatibility and was not able to produce as evidence in the court as well. So single model was being carried out in multiple researches where only one kind of method was used as a source of evidence and was vulnerable to different types of attacks. So this research is an improvisation to the existing, where we are using multiple model as a fusion with the help of automation um, from these AI ML, and with that we are using this. With that way, we are building a system. So this is multi-model approach where we are using four main forensic terms such as RGB, ELA, noise residuals, DTC, and other, which are significant impact upon the forensics. So this emphasizes forensic complementarity. For example, an image having a perfect RGB consistency but is having a noise pattern can help us to identify if the image is tampered or not. Even same with all other modules, which I'll be explaining them shortly. So coming to the RGB is because every image will be having its own complexion, like in the pixel sense. So if anything is tampered, we will be able to identify it with the help of the RGB content. If there is a weak low, the it can be fooled by it can be fooled by the detector. So this one will help us to know if there are any unnatural textures, sharp boundaries, or semantic inconsistencies in the image. So error level analysis is another one, which is ELA. This is this helps to know if the images, like the edited regions often have a different compression signature than the surrounding image. So ELA will help us to know if that image has been taken from from a single uh, thing, or if it was tampered in between. So the noise residual allow us to see whether an image was captured by one or multiple devices. Splicing from different cameras leaves distant noise prints on them. So this will be analyzed using the noise residual. So the another one is the DCT, which are used to know if there was any tampering, micro tampering, which has occurred on the image. So even the DTC catches subtle changes in the frequency pattern that even human can't see. So that withstands all other detectors effect. So this is the whole architecture diagram where the image has been uploaded and it has been sent to all four forensic analysis, and they are having different CNN encoders which work as a fusion layer and classifies the data using and classifies the data and helps to know if the data is tampered or not. So if it is tampered, it will be produced, even if it is tampered or if it is the original, it produces the hash functions. It will give the result as a web result to the user, which is a forensic expert, and he'll be able to know the file name, the analysis timestamp, everything being included in the same document. He or she will also be having a risk analysis graph, which will be able for them to get into this. So the data has been, this is the methodology where the data set has been taken from the Kaggle, and it has been splitted among um, testing, validation, and training part. So evaluation has been done under three parts, which I'll be explaining over the code. So coming to the core, so this is the code of the program where we could see that the all the few parts are the import parts of all whatever is required for the entire program to run. So entire import is happening over here. We have also set coda, or where it will be identifying which processor can perform this function. This is where the data set is being called upon, and this is where the function, where the hash lab is used to hash the whatever image is being given is being hashed to this value using hash lab, and that has been done over here. And then the data has been splitted into testing, validation, and training part over here. Here is the error level analysis that is being conducted over here, where the image is being computed to in the format of JPG, and it is being computed. The noise, like if there are any tampering, is calculated over here. That is where that will help us to know if there was only single source of image. The DCT effect, which captures the minute effect of the image, is being captured over here. So all these are being loaded to this forensic data set, which is having its own CNN encoder. So that captures all the data from there, and it loads into the data. So that all thing are happening over here, which is then future over here. So the accuracy of this one is being noted over here using a training model. So the score is being tested out here with the F1 F1 score. Also, the confusion matrix is being labeled over here to help us know how accurate our model is from others. So these are the main results of validation which is happening. So this is over the matrix, the ROC curve, which is having a high precision call of this curve. So all this experimental analysis has been successful in this scenario, where all four has been taken into consideration one by one model. and then this is being generated as a final report of the training, with 50 epochs being done and the training rate being 1. So that will help us. That was used to identify the best um, training model for this one. And these are all other codes which is used um, to know if how many percentage of RGB ELA noise is there in an image. So this is the intensity of all the. This is a graphical representation of the data which we had submitted for the testing part. So, and going on to the application part has been set up with all security measures. It is a web application which is held for running. So this is run made under the Flask app, which is another environment which helps in this purpose. So the forensic data has been loaded to here, and keeping under the consideration that all these data, all this application needs to be stored, and web application should be protected from any source of attack. All those are kept into consideration, and the security measures are given to this over here. So that's one of them is Talesman, um, which is help to know. So this is the entire application of the program. So this is the anomaly chart, the modularity chart, and everything being given. And this is the plot chart, which will help us to know the risk analysis of the chart. So, and this is the web page coding, which is given as well over here. So we have to in a isolated environment is where I'm running this right now. So I'm opening this inside another environment, and I'm hosting it over here. So this is done here. So I'm running it on the server. I'm just clicking them. So this is the model where the forensic expert um, get to see as a user interface. Here they can upload the image, they can analyze the image, and that will let the user know what is the SHA MD hash functions, hash values of that program, along with the time of analysis and the file name, everything. They can download the BNG report. So this consists of zip file which has a complete forensic report, as well as individual diagrams of each of the graphs, and with the severity of what they are being shown. So if it is a highly, it will show the risk as high, and it will tell the amount of error level, noise, and descriptions in that image. And these are the main things. So coming to the, so these all have been kept into mind, and this is a risk analysis. So this is extremely there were many challenges while making them. Even micro manipulations can be detected, but it was hazardous to see if any micro tampering happens. It was a hard time to capture that. So even extreme JPG degradation is happening over here. So this supports evidential integrity and chain of custody, and is a highly advisable for legal purposes. So in future we would like to extend it over cross media, like using video and audio, and with the higher data set expansion, higher the results. So I would like to explore over that part, and thank you.